Alright, hello and welcome back. So today we're going to look at thermochemistry. And there's this one worksheet in particular that's in the packet that was giving a lot of students trouble. First of all, there's a lot of information on this sheet, and the information is slightly new, so I can definitely see why people are having problems with it. In a previous video, I already went over some of these terms, but let's just recap. Right here we have a table, and it tells us that this is water. Notice that we have water in three different phases: solid, liquid, and gas. And it gives us the specific heat for each phase. The specific heat is the amount of heat it takes to raise the temperature of 1 gram of that substance 1 degree Celsius. So if I have 1 gram of liquid water, I'm going to need 4.18 joules to raise the temperature 1 Celsius. And if you look here, we have to make sure we understand the units. This is joules over grams times Celsius. They also provided us with the specific heat of some other substances: aluminum when it's a solid, benzene when it's a liquid, and ethanol when it's a liquid. Yet again, keep in mind the specific heat of a substance depends on the phase that it's in, because the intermolecular forces will be greater or weaker. So it's going to take more or less heat to break those forces apart. Let's go down here. Now we have heat of fusion, heat of vaporization. They provided us this number for some different substances: water, benzene. You notice here that it doesn't say solid, gas, or liquid. It just says heat of fusion and heat of vaporization for water. This is also referred to as enthalpy of fusion and enthalpy of vaporization, which I talked about before. But we don't want to go into too much detail to get you confused. Really what this number means is, if I have water and that water is solid, how much energy is it going to take to break it into liquid? This number means if I have liquid water and I want to completely break all of it into gas, to vaporize all of it, how much energy do I need? Notice that these units are different than these units. This is kilojoules per mole, whereas these are joules per gram. So we have to keep that in mind when we're doing this worksheet. Down here they provided us with the molar mass of these different substances. And they've also given us the boiling points and melting points in Kelvin. Remember, to convert from Celsius to Kelvin, I add 273 or subtract 273. Let's go down and look at some of these problems. First of all, I have some of the equations we're going to be using. We have heat equals mass times specific heat times the change in temperature. So the change in temperature means I need to know the starting temperature, the initial temperature, and also the final temperature. This little triangle just means change. So I have to have two numbers to figure out the change: the final number and the beginning number. Down here, the enthalpy of fusion, or we could just say the heat of fusion, equals the number of moles of the substance plus the enthalpy of fusion number, or heat of fusion. Same thing for heat of vaporization. Now, to go back to this really fast, I want to point out that basically previous chemists have sat down and figured out these numbers for all of these different substances and their different phases. So you're not really required to memorize any of this. These are going to be on tables in books or provided on a test. However, it's good to know the specific heat of water. I think that's one you should probably memorize: 4.18 joules per gram, or this is 1 small calorie per gram. Let's go on to the questions. How much heat is required to melt 25 grams of ice at 0 degrees? Okay, well, notice a couple things. They only gave us this one temperature, and also we're melting it. This is what requires us to think a little bit. Some people would go up here to this table, they're looking at specific heat, they're like, oh, liquid, and they're looking at this number, but we're trying to take all of this water that's a solid, and we're trying to melt it. And remember in the previous video I talked about how at that point in time the temperature is not increasing because all the energy is being used to break apart the intermolecular bonds. So if I'm trying to take something and melt it, I'm trying to change the phase of it. That's when I need to use the heat of fusion, right here. I'm trying to change the phase of water from solid to liquid, which is the heat of fusion. So 6.01 kilojoules per mole. Well, let's go down here. My other problem is I have grams. So I have this number, 6.01 kilojoules per mole, but that's not going to help me unless I know how many moles of water I have. Sorry, how many moles of ice that I have. So let's go ahead and convert this. We have 25 grams of ice. We're just going to do some basic stoichiometry. 1 mole of H2O is roughly 18 grams. Now, where am I getting this number? This number is the molar mass. So I could go to the periodic table. I could look up hydrogen and oxygen, and I look up the molar mass of these substances and add it all together, like we've done before. Or, they already gave me that number in this table. They had a little bit more specific, but it's right here, 18.02. Okay, now, I know that I need 6.01 kilojoules of energy per mole. That's actually a conversion factor when I think about it. If I put 1 mole here, I know it looks kind of weird because it's this, but really in reality it's kilojoules, 6.01 kilojoules over mole, 1 mole. That's really what that's saying there. And I'll put 6.01 kilojoules. And then all I have to do is do some math. 25 divided by 18 times 6.01. Notice the grams will cancel out and the moles will cancel out. And I will get around 8.34 kilojoules per mole. Well, actually it's just kilojoules. So that's how much energy I'm going to need to melt 25 grams of ice. Now, why do they even provide 0 here? Because remember, at 0 degrees, that's when solid ice turns to liquid. And if you didn't know that, they actually gave us that as the melting point. I know I said that you have to plus or minus 273, but basically it's a little bit, it's like 273 point whatever. So this is really 0. That would be the melting point of ice. And one thing you want to do is get comfortable with converting from Celsius to Kelvin. Okay, let's go down here. How much heat is required to melt? So yet again, we have this term melt. And whenever we look at these questions, we have to read these carefully and figure out what are they asking us. 25 grams of benzene. So this is going to be similar to this problem, except I have to use a different heat of fusion. So I'll have 25 grams of benzene. I want to convert it to moles. Now I need to know the molar mass of benzene. Let's go up here. 78.12. I also need to know the heat of fusion of benzene. And they have provided that for us right here, 10.59 kilojoules per mole. Yet again, kilojoules per mole. So I do the math, and I find it's around 3.2 0.38 kilojoules. Well, this doesn't seem too bad. Let's go down to the next one. Now we have some different terminology. Boil away. What does that mean? Well, this is basically saying if I have it in liquid and I vaporize it. Think about water boiling on the stove. It's just all boiling there. And if I boil all of it away, it's all converted into gas. So this is ethanol. So I will use 25 grams, 1 mole. Now let's go find out the molar mass of ethanol, 46.08. And I need to know the heat of vaporization, the enthalpy of vaporization of ethanol, not fusion, vaporization. So it's 43.5 kilojoules per mole. 1 mole is 43.5 kilojoules. And I'll get around 23.60 kilojoules. And they're asking me the same question here. How much heat is required to boil away 25 grams of acetone? 25 grams, 1 mole. Let's find the molar mass of acetone, 58.09. Okay. Grams, 1 mole. Let's find the heat of vaporization. Acetone. The heat of vaporization is 29.1 kilojoules per mole. Do the math, and I'll end up with somewhere around 12.48 kilojoules. Okay. That all seemed pretty straightforward. Notice that we didn't even use this equation right here at all. We were really just using the enthalpy of fusion and vaporization because the temperature really wasn't increasing. They didn't give us two temperatures. Well, let's go down to this second part of the worksheet. This is much more difficult. Okay, we have a sample of water with a mass of 23 grams at a temperature of minus 46. How many kilojoules of heat energy are necessary to heat the ice to 0? Well, let's think about this. It's at minus 46, and we want to go to 0 Celsius. So right up to the point where it's going to turn into a liquid. Notice they're giving us two temperatures here. We have a starting temperature, an initial temperature, and we have an ending temperature. And also it's not going through a phase change. It just says we're heating it. We're not boiling it away. We're not turning it to something else. So in this case, I need to go back and use Q equals, I just say MCAT. Q equals MCAT. So the amount of heat we're looking for is going to equal the mass times the specific heat times the change in temperature. So let's go down here. The mass that we have is 23 grams. Q equals, I'll just write here, Q equals mass times specific heat times change in temperature. Our mass is provided as 23. What is the specific heat? Well, let's go back to our table. Now we have water, specific heat. This is where people get confused because they will pick the wrong phase and they will get a wrong answer. So remember, it's a solid. Water doesn't melt until 0 degrees, so it's a solid. It's 2.06 joules per gram. 2.06 joules per, this is 23 grams. So this is joules. Theoretically, this is joules per gram, if you think about it. And now I need to find the difference in temperature. Well, my difference in temperature, my delta T, is going to be my final temperature, which is 0, because I'm going to 0, minus 46. So it's 46 degrees. Now, think about the grams cancel out. And in the end, I'm going to end up with the amount of joules that I need. So if I do this math, 23 times 2.06 times 46, I'm going to get 2,179 joules. Okay? And actually, I forgot to tell you, this was joules per gram Celsius. That's what the actual units are in the specific heat. And this is actually Celsius here, so the Celsius cancels out also. That's why we end up with joules. Now we just put a little square around here. We feel happy. Now we want to melt the ice. Okay. So we've taken the ice from minus 46 degrees to 0. But now we want to melt 23 grams of ice. Well, think about it. This is exactly what we were doing in the previous problems. We need to use the heat of fusion. This is when we take something from a solid to a liquid. We're melting ice to a liquid. So the heat of fusion is 6.01 kilojoules per mole. I have 23 grams of ice. I have to convert it into moles again. Why? Because I have 6.01 kilojoules per mole. So I have to figure out how many moles I have. 1 mole. Remember, the molar mass of water is 18 grams. I have I'll use my conversion factor. 1 mole equals 6.01 kilojoules. Okay. Now, excuse me, I'm a little sick, so I'm trying my best here. Now, the grams cancel out, the moles cancel out. I do my math, and I get 7.67 kilojoules. Okay, we're making some progress. I think we're feeling better about this now. Now, yet again, we're heating the water. Notice it says heating the water. Here it said heating the ice. We're heating the water. It's liquid from 0 to 100 degrees. Why 100? That's basically the heat of vaporization. That's when it's going to boil and turn into steam. It's the boiling point. So, yet again, I have to go back to Q equals MCAT. Q equals the mass, 23 grams, times the specific heat. But now this is liquid. So I can't use the specific heat of water. Solid ice. I have to use the liquid. So it's 4.18 joules per gram. Notice the big difference here. 4.18 joules per gram Celsius. And I have a 100-degree difference times 100. How do I get that? By change in temperature. It's going to be the final 100 minus 0. So it's just 100. Now, I multiply this out. Look at this. Celsius cancels, grams cancel, and After I do this, I will get 9,614 joules. Okay, now we want to boil the water. So we have to go back to this method. We have to use the heat of vaporization. We have 23 grams, 1 mole is 18 grams. Now what is the heat of vaporization? It has it right here. Look how much of a difference that is. It takes a lot more energy to take this water and turn it into gas than it did to take the ice and turn it into a liquid. This is 40.7 kilojoules per mole. 1 mole is 40.7. Sorry, it's kind of hard to see kilojoules. Okay. Now I do the math. Look at that. Moles cancel, grams cancel. I'm going to end up with kilojoules. My number is going to be around 52.05 kilojoules. Okay, now we're going to heat the steam. Our water is gone. The ice is gone. The water is gone. All we have is gas, which is steam. They want us to further heat it from 100 degrees to 109. So yet again, I got to go. See how they give us two temperatures? I need to use this Q equals MCAT. So Q, heat, equals the mass, 23 grams, times the specific heat. Yet again, be careful. The specific heat here is not a solid. It's not a liquid. It's a gas, 2.02 joules per gram Celsius. 2.02 joules per gram Celsius. And it's going to be 9 degrees difference. If I do the math here, I'll get 418 joules. Yet again, how did I get this 9? My final temperature, 109, minus the starting temperature of 100. Just to make sure you understand that. Okay. Now, if I had to add this all up, I would have to do one thing first. You may have noticed that sometimes they're kilojoules and sometimes they're joules. So if I wanted to add all these up, I would have to convert all of them to be the same unit. So if I want to take a joules, and make it into kilojoules, I would have to take this number divided by 1,000. And that's by using basically the metric system. But just think about it. King Henry doesn't usually drink chocolate milk. If you use that acronym, this will help you understand how you convert this. And we can go over that later if you need help. So I would have to divide that by 1,000, divide this by 1,000, and divide this by 1,000. Then I would have to add it all up. And if I added it all up, I would get my answer in kilojoules. I could say, well, it's going to take this many kilojoules to convert ice at minus 46 to steam at 109 degrees. Okay, well, I hope that helped you out. We're going to do a few more practice problems with this, so don't panic if you don't understand it. But I hope that's a good start. Yet again, if you have any questions, let me know.